This function has two partial derivatives. One is with respect to x1, and one is with respect to x2. Okay? What's the partial derivative of this function with respect to x1? Any ideas? Well, to find that, I have to treat x2 as a constant, so all of that's irrelevant. So it ends up being 2 times x1 minus 2 plus 2, because I have this. So it ends up being 2x1 minus 4 plus 2, which is 2x1 minus 2. With respect to x2, it ends up being minus 2 times x2 minus 3. Do we agree? So those are the partial derivatives, and the idea behind the gradient is that you put them in a vector together. And that vector is called the gradient vector. And the symbol for it is this upside down triangle. Does anyone know what it's called? It's called a nabla. That's the upside down triangle. Okay? And the idea is you want to think of, there's a typo here, but you want to think of this function that takes in an x1 and x2 as really being a function that takes in a vector and outputs a single number. Okay, it takes in a vector, x, that has two components, x1 and x2, and does first component minus 2 squared plus 2 times first component minus second component minus 3 squared. So it's a function that takes in a vector and outputs a single number. So we might say something like function that takes in a two-dimensional vector and outputs a single number, a scalar. Okay? And the function takes in vectors, and so the gradient of a function is also a vector in the same number of dimensions. Just to familiarize ourselves with the idea of a gradient, here's an example of a function that takes in vectors that you saw in discussion last week. It takes a vector, x, and does x transpose x. Okay? What is the value of x transpose x? Like, is it a number? Is it a matrix? Is it a vector? What is it? Yeah, it's a single number. It's a scalar. And it ends up being x1 squared plus x2 squared plus all the way through xn squared. Okay? And the partial derivative of this function with respect to any one of the xi's is just 2 times that xi, which means the gradient vector is 2x1, 2x2, all the way through 2xn, which is just 2 times the vector x. And so again, the function takes in a vector as an input and outputs a scalar. Its gradient is also a vector. Sound okay? All right. Now what does the gradient tell us? Well, at a particular point, the gradient tells us the direction of steepest ascent. Okay, it's telling us the direction in which the function is increasing the quickest. Right? There's lots of ways the function could increase. Like that way increases the function. So does that. So does that. So does that. But the gradient tells me where it's increasing the quickest.